Should be able to calculate density given objects. And so if we look at a bowling ball and a volleyball, and I were to ask you which one has more density, well, you would.
Okay, so looking at a bowling ball and a volleyball, I want you to think, if you've ever held a volleyball, you've ever held a bowling ball, you probably have. Which one is more compact and basically has more mass?
Bowling ball.
Yeah, the bowling ball is going to be a bit heavier, it has more substance in it, it has more mass in it. The volleyball is pretty much made of air, where the bowling ball probably made mostly of harder plastic. Okay?
Do we
so
have
it's going to have more density. Yes.
Do we have to copy the questions?
Yeah. You just copy and paste.
I know, but when we look, we don't know which one we answer.
You would know that that bowling ball has more material on the inside. If we were to cut it open, you would find that the volleyball is empty. It's filled with mostly air. But that bowling ball is going to be filled with lots of matter on the inside. And so now, even though the volumes are the same, since the mass of the bowling ball is much higher, it's going to have a greater density. So you should be able to make predictions just by looking at objects, and even looking at how objects change over time. What would happen to the density of a volleyball as we heat it up and those molecules move apart? It would become less dense, and as we cool.
Okay, so what is the formula to calculate density? Oh, right here. Let's see it. It says mass divided by volume, volume divided by mass, or mass times volume. What's the answer? What's the answer? Huh? First one, second one, third one. First one. Okay. It's right on the screen, mass divided by volume. So to find density, you are probably going to have to calculate this on the test because there's 5 density questions on the test. So you're going to have to use mass and volume to calculate. So there's going to be mass divided by volume.
Cool it down, it's going to become more dense. And so this is a PHET simulation. What we're going to do is look at some different objects and figure out what their density is. And so what we've got here is a little bit of styrofoam. And I'm going to stop it right here. We can see that it has a mass of 0.75 kilograms and then a volume of 5 liters. And so how do you figure out the density? It's simply the mass divided by the volume. And you can see the density right here is 0.15 grams per liter. And so now let's change that from styrofoam to wood. You can see that the volume stayed the same, but the mass, since it's 2 and the volume is 5, we now have a density of 0.4. You'll also see that it's still floating in this water we have to the side. Now let's switch that to ice. So if we look at ice, what is our mass? Mass is 4.6 kilograms. What is our volume? It's 5 liters. And so you can see that the density is 0.92. Now it's approaching 1. And what has a density of 1? That's going to be the water itself. And so since it's less dense than the water, you can... So
what is the density of water? Remember to write a number and the appropriate unit next to the number. So water has a density of 1. Okay? So you can write down 1 kilogram per liter.
And the volume is 5. We now have a density of 2. You'll also see that it's still floating in this water down to the side. Now let's switch that to ice. So if we look at ice, what is our mass? Mass is 4.6 kilograms. What is our volume?
Okay, so if we're dealing with water, if something sinks in water, is it going to have a greater density than water or less than water? If it sinks.
What?
The question is, if something sinks in the water, is the density going to be more or less than water?
More.
More. Okay, so it's going to be heavier if it sinks. If it's less than 1, it's going to be less than water, and it will float.
You can see the ice is floating. It's not floating as high in the water as the wood and the styrofoam did, but it still is floating. Now let's switch.
Okay, so what happens if something is more dense than water?
Yeah.
So objects sink or does it float? Instead of it does sink if it has more density.
Switch that to a brick, and what happens there, you can see that our mass is twice that of our volume, so now we have a density of 2 kilograms per liter, and it definitely sinks, and then we can move it to something like aluminum, and we have a much higher mass compared to that volume, and so we have a high density, so that's why it sinks. Now what you should be able to do in this physics class is calculate the density of an object. So I'm going to take object B, and we're going to weigh it. We can figure out what its gravitational mass is. It's 0.64 kilograms. Now I'm going to use water displacement. So you can see the level in the water is 100, but as I add object B, the level in the water goes up to 101. Now let's take object A, get its gravitational mass. You can see it's 65.14. And now let's use that displacement of the water again to figure out what's the volume of that cube. You can see it went up to 103.38. And so could you calculate the density of those two objects? And could you figure out if they're going to sink or float? And so here's the important information that you need. You can see that both of them started with a water level at 100 liters, and with object B that rose to 101 liters, and it had a mass of 0.64.
Okay, so your test question, they're probably going to give you an object, they're going to probably give you the mass, and they're probably going to make you figure out the volume. Okay? So we do have all the information here to figure out the density for A block and B block. For A block, the mass that was recorded was 65.14. Okay, so for A block, the mass is going to be 65.14 kilograms. This is measuring the mass. The volume, the water started at 100, but when you put the block in, it rose to 3.38. So that way you're trying to find out the volume of this block. How much water did it move to determine how much volume they have. So 100 minus 103.38 is basically 3.38 liters. Okay? So now I have mass and I have volume. So with these two things, I can calculate the density. So I have to punch in, use your calculator, your phone, or whatever, 65.14 divided by 3.38 is actually equal to 19.27 kilograms per liter. So you gotta put the units in, but that is measured in. Okay? So that means the density is equal to 19.27. We said that water has a density of 1. If your density is higher than 1, it's going to sink. If it's less than 1, it's going to float. Is 19 higher than 1 or lower than 1? Higher. So if it's higher, it's going to sink. Okay? So that's part of the last question. The other part is B block. We have a mass that he measured, 0.64. So 0.64.
Can't even put on no fit. All these niggas, they be cow. I just be running with the glizzy. We got ARs, we got Mac. I ain't trying to catch no feelings. Hold no screen, don't get attacked. On my back, I put my city. I'm gon' carry them till I can. Put them on my back, carry them till I can. Shit running in my jeans, I'm inherited to them rats. GCM, just follow up. You already know what's up. I just caught me 2 ARs, I'm gon' run down with both of them.